Okay, in the last section, we saw that algebra tiles cannot be used to multiply everything. And we don't want to have to draw algebra tiles to multiply every single time we need to multiply. So we're going to look at different ways of multiplying monomials in two variables. One thing that we use a lot to multiply my monomials is to remember multiplication is commutative. What that means, commutative, move, is the factors can move. Factors, that's an O. Factors can move when all you're doing is multiplication. So like this previous problem, when I had 3x times 4x to the second, this is just 3 times x times 4 times x to the second. I can move them around, meaning this is all a multiplication problem. There's no adding, there's no subtracting, just multiplication. I can multiply the 3 times the 4 times the x times 2 more x's, because there's my x squared. And now I can multiply the 3 and 4, I can multiply. That gives me a 12. Now how many x's am I multiplying? 1, 2, 3. I'm multiplying 3 x's, okay? Or think of it as this is x to the first. I'm adding the exponents. If I have x to the first times x to the second, that's going to give me x to the 1 plus 2, which is x to the third, which is what I got. And this is our product of power property that we did way back in chapter 1. When I am multiplying two things with the same bases, they have to have the same base, A. You add the same base, you add the exponents. And that just comes from that property of exponents that we did up here, that when you're multiplying, it's how many times you're multiplying. So if you can't remember, what I love about this property is if you can't remember it, that's okay. You can still write it all out and add up how many you're multiplying. So here, if I want to multiply negative 2 times a to the second times b to the second, so doing this example right here, again, I always write it as negative 2 times a to the second times b to the second. I put those multiplications in there. Times negative 5 times a to the seventh times b. So now I can multiply. This is just as strictly everything going on in here is a multiplication. So I can multiply in any order. I'm going to multiply the negative 2 and the negative 5. Negative 2 times negative 5 is 10. Now I can multiply the a's. I'm going to write it out. A to the second times a to the seventh times b to the second times b. Now, if I remember this rule, I notice that these two have the same bases, both a, so I can add the exponents. 2 plus 7, that would be a to the ninth. So I have 10 times a to the ninth times, now here I'll need to put an exponent on b. Again, if I remember the rule, b to the second times b to the first gives me b to the third. So I would write my product as 10 a to the ninth b to the third. We write our exponents, our variables, in alphabetical order. So I do the a's before the b's. Okay, so I do it in alphabetical order. So 10 a to the ninth b to the third would be the multiplication. If you don't remember, sidebar, if I don't remember the rule, write it all out. 10 times 2 a's. 1, 2, 3, 4, 5, 6, 7. There's 7 more a's. So here I have a total of 9 a's, a to the ninth. And then I have multiplying by 2 b's. There's b to the second and 1 more b. So I have b to the third. What's nice is if you don't remember this rule, you can get to the rule quite quickly. It's a lot of writing, so you have to write it all out, but you can get to that rule. Okay, same is true for the next ones. If we have the power of a product. So this one's slightly different in that if you notice the bases are different. I'm multiplying, I have a times b to an exponent. This exponent then applies to both of them. So basically if I have, for example, 3x to the second, that's going to be 3x times 3x. So the 3 is also getting multiplied twice as well. So it would end up being 3 to the second times x to the second which is 9x to the second. Because that second applies to both of them because of the parentheses. Now, if the parentheses weren't there, that wouldn't apply. Because variables only apply to the thing directly in front of it. For example, if it was written this way, that 2 was only on the x. It's 3 times x to the second. Okay. And that's here, this rule, if I have the power of a power. Okay, for example, x to the second to the third. This means I'm taking x to the second and multiplying it 3 times. Hence, I'm multiplying it 3 times. I'm multiplying 3 times. Times is the multiply, right? So I'm really multiplying 2 x's and 2 x's and 2 x's. So I'm really multiplying 6 x's, which I can get by using this shortcut by just taking the 2 times the 3. Okay, which is the same as x to the 2 times 3, which gives me that x to the 6th. So really, I think of these rules as just shortcuts. They're shortcuts to us having to write it out so many times. Okay. All right, so let's go ahead and let's look at this task 4. So we want to find, here we have 2 times x to the 4th times y to the 3rd to the second power. So I'm going to do it one way as if I don't remember the rules, and then we'll do it the other way with the rules. So here, this is 2 times x to the 4th times y to the 3rd to the second. So that means I need to multiply this twice. So 2 times x to the 4th times y to the 3rd times 2 times x to the 4th times y to the 3rd. So I can multiply the 2 and the 2. That gives me 4. And then I have x to the 4th times x to the 4th times y to the 3rd times y to the 3rd. X to the 4th, that's 1, 2, 3, 4 x's. 1, 2, 3, 4 x's. So really I have a total of 8 x's. So I'd end up with 4 x to the 8th. Now let's do the same thing for my y's. This is 3 y's. And this is 3 y's. So I end up with 6 y's. Y to the 6th. So I have 4 x to the 8th, y to the 6th. Ta-da! Okay. Let's do it with the rule, with the shortcuts. Oh, wait. With the shortcut. So now over here, we're going to do it using the shortcut. So we have 2x to the 4th, y to the 3rd, to the 2nd. Okay, so here I have a multiply in here. So I'm going to use this rule first. Because I have a parentheses with an exponent on the outside, this exponent now goes to everything in there. So I would have 2 to the 2nd times x to the 4th to the 2nd times y to the 3rd to the 2nd. So that was using the power of a product. Okay, that was using that first rule. Now 2 to the 2nd, well, that's 4. Now I have x to the 4th to the 2nd. So now to use this rule, I have x to the 4th to the 2nd. I multiply those exponents. So this would be x to the 4 times 2 times y to the 3 times 2. So I'd end up with 4x to the 8th, y to the 6th. Did I get the same answer? Absolutely, I did. Now, which one took less work? I don't know. It kind of was about a horse apiece. Each one was about 4 lines. The problem, and then 1, 2, 3-ish lines, 1, 2, 3-ish lines. So they weren't really all that different. It's just if you remember the rule or not. And if you don't remember the rule, that's fine. Just write it out longhand to still get there. Okay. All right. So now we have one last task with our home aquarium. So here we have a home aquarium. It can be cylinders, cylinder right there, or rectangular prisms right here, as well as other shapes. Aquarium A and aquarium B are shown. What is the volume of each aquarium? Okay, so first of all, volume. Volume is what? It's the number of cubes inside. The number of cubes inside a figure. Okay, so to find the volume of any prism like this, B, I take the area of the base, area of the bottom, times the height of the cylinder, or how many levels. Basically, I figure out how many cubes would it take to cover the bottom, and then like how many layers would I need to fill it to the top. How many cubes would I need to fill the bottom, and then how many layers to get to the top. So let's go ahead and let's do that for aquarium A. Well, the bottom is 2x by x. So for the volume, I would take 2x times x. That's the area of that base. And then it's x high, so times the height, which is x. So I'm taking 2x times x times x. So 2 times x times x times x, which will give me 2x to the 1, 2, 3. 2x to the third. So that's the volume of that one. Okay, volume of B. Okay, this one's a little bit different because the base is a circle. I need to figure out how to find the area of a circle. If we don't know, we can search it real quick. The area of a circle is pi, area equals pi times r to the second. So I need to take pi times the radius. Okay, now the radius on this guy, they show it as the full diameter all the way across. They have this going all the way across. So this right here is the diameter. So the whole way across is 2x. So only halfway across would be 1x. So the radius would be 1x. So I have pi times 1x to the second times the height of the prism. How tall is it? Well, it's 2x's. So I have pi times, I'm going to write it as x times x times 2x. So I have 2 times pi. We'll just write that as 2 times pi. 3x to the third. So 2 pi times x to the third. Okay. So how do the volumes of the two aquariums compare? Well, let's compare them. They both have a 2. X is the same since it's the same problem. X is the same in both of them. So whatever the one x is, the other x. So they both have x to the third. The cylinder, though, is multiplied by pi, which if you don't know, pi is approximately 3.14. So the aquarium B has that extra pi multiplied in there. So it's going to be pi times bigger. So how do the volume, so aquarium B is, so B is larger. And it's pi times larger because it has the pi multiplied in there. B is larger, it's pi times larger. How do the volumes of the two aquariums compare? Will one aquarium always have a greater volume given these dimensions? Yes. B is larger, it's always going to be pi times larger given these dimensions.